Today we'll do three derivations, or we'll try to do three derivations together. That is AC circuit through resistor, capacitor and inductor. That is, we'll find the relation between I and V in case of a resistor, capacitor and an inductor. So firstly we'll start with the resistor. So we'll consider a resistor of resistance R. Resistance R, which is connected to a voltage that will be E is equal to E naught sine omega t. So we have a resistor R and it is connected to a voltage that is E is equals to E naught sine omega t. This symbol represents alternating current. So we'll do it. So as we know, E is equals to E naught sine omega t. We can write E as Ri equals to E naught sine omega t. So we can write I is equals to E naught by R sine omega t, and this is known as I naught sine omega t. So what is basically I naught? I naught is the alternating current that we are talking about. So this is the relation between V and I for a resistor. So next we'll do the derivation for the relation between V and I for a capacitor. Second, capacitor. So same assumptions. Consider a capacitor of capacitance C which is connected to a voltage E is equals to E naught sine omega t. So we have C and we have the voltage. E is equals to E naught sine omega t. As we know, Q is equals to CV, and we can write Q is equals to C into E naught sine omega t, and I is equal to dq by dt. So I is equal to d into C E naught sine omega t by dt. So we get I is equals to d by, we'll take C and E naught outside, we get omega and we get cos omega t after derivating sine omega t. So we can write it as E naught upon 1 upon C omega into cos omega t. We have just taken the C omega in the denominator. So, and this is known as XC, which is known as the capacitance reactance. So we have I is equals to E naught XC cos omega t, and we can write cos omega t as E naught upon XC sine omega t plus pi by 2. So what is the final answer that we get? That is this. I is equals to E naught by xc sine omega t plus pi by 2. Also, I naught will be equal to E naught by xc. And the SI unit for capacitance reactance is ohm. That is same as that of resistance. The next one that we have is the relation between voltage and current in case of an inductor. Third, inductor. So we'll consider an inductor of length L, of inductance L. Consider an inductor of inductance L connected to E is equals to E naught sine omega t. So L and so we know, according to Kirchhoff's voltage law, we have E plus E dash is equal to 0. So we can write E minus L di by dt is equals to 0, which implies E is equals to L di by dt. So E naught sine omega t is equals to L di by dt. We get di is equals to E naught sine omega t dt by L. So when we integrate both sides, we get I here, we get E naught by L outside, and we are left with sine omega t dt. I is equals to E naught by L. After integrating, we get cos omega t by omega and a minus after the integration. So we get I is equals to E naught cos omega t, and we have LW, which is equal to XL. So I is equals to E naught cos omega t upon XL. And what is XL? XL is the inductive resistance. Like we have had the capacitive reactance, this is the inductive reactance, and this is equal to LW. That one was equal to 1 upon CW. So we get I is equals to minus E naught by XL sine pi by 2 minus omega t. So we can write it as E naught by XL sine omega t minus pi by 2. Also, this is I is equals to I naught sine omega t plus pi by 2. Also, the graph for this is, as we can see here, the voltage leads and the current lags. In case of the capacitance, we'll also draw a graph for that. First, we'll draw the graph for this. So it will be somehow, it looks like this. is, we have omega t here, E naught, I naught. So this is the curve, and and, and this is voltage curve, and the second curve that we have is this one, and is a curve for current. This was the graph for an inductor. We also have a graph for capacitor. For a capacitor, the, in the case of a capacitor, the current leads and the voltage lags. So the graph is omega t. This is 90 degrees. Here we have E naught. Here we have I naught. And get this to be this. For I, the curve is so. This is how both the graphs look like. This is for inductor and this is for capacitor. Thank you, and I'll see you in the next video.